In the last unit, you have learned about the different properties of forces, right? From it, we understand that even if we are just standing or sitting, there are still forces acting on us. Not all forces can cause a movement to a specific object though. For example, even if you try to push a sturdy wall, the wall will not change its position. On the other hand, some forces can be used in moving objects like pushing the door to open, pulling your trolley bags, carrying books, and even just moving the objects up and down. In these situations, the forces that causes the change in the position of the object are said to be doing work on the object. Just like the image shown above, the man exerts force to the wheel, making the wheel move. Thus, the person is doing work on the wheel. In this lesson, we will further discuss the properties of forces and how they can produce work. When we talk about work, there are a lot of available definitions we can think of. It could be the activity that we do every day and being paid for the effort of doing it. It could also be something that you exert some effort or time. We may learn the definition of work in science, specifically in physics, but before that, we need to review first about the dot or scalar product. The scalar product consists of two vectors, vector A and vector B as shown in this image. We can write it as variables A and B with arrow on top of them multiplied with one another. With this notation, the scalar product can be also called a dot product. Although A and B are vector quantities, the expression A times B is a scalar quantity. The scalar product can also be written and defined as A times B is equal to AB cosine theta, where A refers to the magnitude of vector A, B refers to the magnitude of vector B, and theta refers to the angle made between these two vectors. The result of the scalar product of two vectors is a scalar quantity. We also understand that vectors can be expressed into their components x and y. To express vectors given by their x and y components, we can use the equation a times b is equal to a sub x times b sub x plus a sub y times b sub y. In some cases, we are also interested to find the angle between the two vectors. We can find it using the equation cosine theta is equal to a times b over ab. Remember these three equations because the concept of calculating the dot or scalar product is what we use in calculating work. With this, we may now have an idea on how to determine the work done by a force that acts on a system. Let us have some examples. Calculate the product of vector A and B that is shown in the figure below. The magnitude of vector A is 10, while for vector B, it has a magnitude of 12. The angle between the two vectors is 50 degrees. We will use the formula A times B is equal to AB cosine theta to get the scalar product of the vectors given. We will then substitute the values 10 times 12 cosine 50 degrees, and the final answer would be 77.13. Quite easy, right? Let us have another example. Find the scalar product between A and B that is shown in the figure below. I will let you do this problem. Examine the figure first. Afterwards, look back in the equations I have given to you a while ago and try to find the scalar product. Okay, let us see if we have the same answer. The magnitude of vector A is 18. The magnitude of vector B is 12. The angle between the x-axis and A is 70 degrees, while the angle between x-axis and B is 138.0 degrees. We are interested to find the components of these two vectors, and therefore, in order to get the scalar product, we will use the formula A times B is equal to A sub x times B sub x plus A sub y times B sub y. Before calculating the scalar product, let us determine first the x and y components. For x component of vector A, we will multiply 18 times cosine 70 degrees, which is equal to 6.15. By convention, we round off our answers always to the nearest hundreds. Then, for y component of vector A, we will multiply 18 by sine 70 degrees, which is equal to 16.91. How about for vector B? What are its x and y components? That is correct. B sub x is equal to negative 8.92, while b sub y is 8.03. Now that we have the components, we will substitute the given values as follow. Solving this, we will have 80.93 as our scalar product. In the next video, we will apply this concept in solving work, both done by constant force and by varying forces. This is Gilmar De Castro, and see you in the next video.